How you doing, everyone? I'm Sean O'Kane, and welcome to another edition of Chip Estimate TV, where we bring you the latest trends and information on IP, semiconductor design, and manufacturing in the EDA industry. My guest today is our world traveler, Mr. John Blyler. He's the president and CEO of Semi-IP Systems and IoT Embedded Systems. Thanks for joining us today, John.
Thank you, Sean.
All right. So, a lot of our conversations around the IoT. There's been a lot of talk about that, Internet of Things, where billions of devices will be connected. But yesterday, you and I had a brief conversation about the IoT, the Internet of Avionic Things. What is that?
Just like it sounds, it's the Internet of Things technology applied to aircraft, control systems, communication, and then passenger infotainment. Mm-hmm. And in the same venue, it's a talk of sensors and signal conditioning and connectivity and then handling all the data.
Excellent.
But, this is what I'm going to focus on. I'm going to focus on the connectivity and the sensor part, if that's all right with you. And let me start by asking you a question. So, who is credited with starting the Internet of Things?
Okay, I don't think it was Al Gore. However, I did a wiki search and found out Al Gore was actually credited for inventing spam.
Spam?
Not the email spam, but the food.
Food spam.
Now, who was it?
Nope. It was a Baron Schilling of Russia back in 1832. And because of his invention of the electromagnetic telegraph, machine to transmit electric signals wirelessly or wired. So think Morse code. Mm-hmm. And that was far more reliable at the time than drum beats or smoke signals or things like that.
All right. Well, that's really interesting. But what does that have to do with the IoT in the avionics or aircraft market?
Right. Well, it all comes down to that aircraft already have a bunch of sensors, and they're getting a bunch more, and that's going to result in a lot of good things. It's also going to result in a lot of data.
So that's a lot of data, which means there's a lot of sensors.
A lot, several thousand sensors.
Well, that's a lot of data for one aircraft, okay? So how about this? How much data would it take, the amount of data, for an aircraft to fly from the West Coast to the East Coast and back without being taken off of a United Airlines flight?
864 terabytes, and that's just for one aircraft, and that's just the engines, right? Mm-hmm. Now that, in perspective, that's several hundred terabytes more than Facebook had daily in, say, 2014.
Okay, and that's a lot of sensors.
It is a huge amount of sensors.
Yeah.
250 now per aircraft, but in the new turbojets, it's more like 5,000.
5,000. So you're not going to talk about all the 5,000 sensors here.
Okay.
No.
No, instead, just to give you an idea of how far we've come,
right,
and just in the sensor and connectivity part, let's go back to the 1980s. Because I was a double E designing and calibrating data acquisition systems for the Department of Defense aircraft. So back then, to give you an idea, you had something like this. Kind of heavy. This is one accelerometer for measuring vibration and frequency, whatnot. With a accelerometer, you need a charge amp. Yes? Mm-hmm. Now, you also have lots of temperature measurements. And with those, if you had any thermocouples, you'd need a reference junction. Again, not a huge package, but another one. And of course, there were other sensors and wires, and there's only a few amount here I'm showing. On the connectivity side, you had one of the things you might have was a stack of FM modulators, so that all the signals would be able to be transmitted wirelessly to the ground station. So really, you'd have a bundle of instrumentation just to measure a few items, right?
In the palm of your hand.
Yep, in the palm of it,
or your cell phone, right?
Well, so that's the thing. So now all of this and tons more fits on a tiny little part of your cell phone. It's just amazing.
I'll be darned. That is. So I do want to mention that you're going to Design Automation Conference. That's our industry, conference every year. You're going to be running a panel with Chip Estimate and ARM and...
Yes, IoT-focused panel.
Right.
I have one other panel, too. It's going to be an IP panel, intellectual property, and that's going to focus more on some kind of transistor and system-level design issues.
All right. Well, thanks for joining me today, all right?
Oh, always a pleasure.
All right. For John Blyler, my name is Sean O'Kane. We'll see you next time on Chip Estimate TV.